Hello, good afternoon, happy Wednesday. Hope everyone has been having a good week so far. I see we have a few people in chat already. Fearless0523, Tasty Boy, Ost 008, I want to say. Johnny MD5, PD Gamer, Kefa, UTZNYX. I don't know if there's any other pronunciation of that. Welcome to the stream. We are going to be doing Web App Wednesday. So exclusively focusing on web app stuff. The previous few, we've just been doing Web Security Academy, which for those of you who don't know is a free educational resource / lab developed by Portswigger, who are the people who wrote Burp, and the guy who runs Portswigger is the guy who wrote the web application hacker's handbook, which is pretty much like the Bible for web application hacking. So we will be doing more of that today. We'll just be doing random challenges. So far we've been putting it at the apprentice level, mostly because when it comes to Web Academy, apprentice level's pretty much hack the box medium. I want to say it's that kind of the practitioner level, the level above. There are some ones make sense, but a lot of them are just so strange and just difficult. They would take hours to solve. So at some point we will move on and maybe do a practitioner one. We might not do a fully random one, like we might choose a category, like SQL injection for instance, and do that. Let me switch to my screen though. I'll show you what I mean. So we have the Mystery Lab Challenge. You can set the level, and depending on the level you get one of these that are that aren't grayed out. I mean, so at apprentice level you don't get like DOM XSS, right? Because even DOM XSS is not something I would expect people at apprentice level to do. When you get to practitioner you unlock pretty much all of them apart from access control, and then back expert, obviously there's only 30 expert labs, so there aren't too many of those. But what I figure, we'll still do apprentice and we'll set the category to any. That'll give us some of these. Then at some point we'll do a practitioner one and we'll just choose a subject and do a challenge. Let's start Stream Raiders though. Where are we? There we go. Okay. If you don't play Stream Raiders, it's a fun game. You just have to click the link in chat and you'll log in using Twitch, and every 5 minutes put a little character on the battlefield and then it's completely automated. Snarb Muggins, I had a strange dream last night that you were in for some reason. You were on a dating show, but that's all I remember. That is yes. That is weird. But thank you for dreaming about me, I guess. Have you covered AngularJS? I've been trying to wrap my head around dynamic single page apps. We haven't covered Angular in that kind of sense. So I tend to be more about the actual hacking of web apps rather than like web app development. I mean, I can give a brief description of single page applications or SPAs if you want. They're not too tricky to understand. Yeah, I mean, honestly, they aren't that tricky. So let me just spend a few minutes doing that. With a traditional web app, you would have multiple pages, right? So in this case, we have Academy Home, right? If we click that, we go to Web Security Dashboard. The actual link looks like it goes to index.html down the bottom left. If we go to Learning Path, right, goes there. But every single time we click, the browser is sending a request to that page, and it's effectively swapping out the page we're on for the page we go to, right? So the URL changes, the content also changes because the URL has been loaded, right? And if we refresh this, we get back to the Learning Path page. But the key thing is that these are all separate pages with their functionality on them. The actual backend might be a bit more confusing. Like, it might not technically be pages in the sense of one actual file per page. There might be multiple pages that use the same file, and that would use something called routes. But that's going into like web development too much. The key difference between a traditional web app and a SPA, a single page web app, is the single page web app, the first thing it does, and in fact the only page on the web app is the index page, and it loads a crap load of JavaScript. And the JavaScript pretty much handles everything. So if there's any authentication, you would click a login form. The JavaScript would create a form for you to fill out credentials. You would then submit it. The JavaScript would then send that request not as a regular request through like a browser, like clicking a link or submitting a form. It would send what's called an XML HTTP request, which is kind of just silly because they were originally supposed to just send XML, but you can send anything. And honestly, most days you send JSON objects now. But the key thing is the request is sent while you're still on the same page. It's kind of sent in the background, right? And then when you click a link, it doesn't load a new page by sending an HTTP request to that page. The JavaScript will know what link you've clicked. It will then call an API again in the background, which will then tell the JavaScript, here's the content that you need to load. Okay. Crucially, it does it all in the background. Now, the URL will change. That's not the browser going to a new page. That's JavaScript changing the URL, which you can do. But the reason that's done is so that if you do click refresh, the same index page will load, but the JavaScript will know which page you were on. Hopefully that makes some sense. All right. Okay, I've missed some chat. Protocol pollution. Yeah, protocol pollutions are slightly different. But yeah, it's related to that kind of app. Just a guy has a technical interview for a web app pen testing position. Can you please tell me your suggestions for the steps I need to take and their order? Like, in what sense? Like, what you should study up on? Because presumably, if you've got an interview for it, you've already passed the first round, unless the first round is a technical interview. Let's do a challenge. How should you approach it? I mean, I guess the timeline would be useful to know. Like, obviously, you're not going to be able to teach yourself advanced web app stuff if it's like in the next week. I just refresh yourself on the basics, really. You know, read over some of the OWASP top 10 stuff, because that's probably going to come up. Make sure you understand how browsers and web apps actually work. You'll probably want to know mitigation steps at least. They probably won't ask you complicated stuff. Like I would expect them not to ask you about like request smuggling or something, or like maybe DOM XSS. But yeah, it's hard because you can really go multiple ways, multiple different directions in a web app interview. So I would just focus on like the basics of web application security, know the OWASP top 10, know how to basically just describe in detail stuff, like if they ask you how a stored cross-site scripting attack works. You know, mitigations are very important, right? It's great to know about cross-site request forgery, but if you don't know how to mitigate it, then, you know, that's pretty much half the job right there. It's telling customers how to mitigate it. But yeah, other than that, those are really the main things I would focus on. Alright. So, for those of you who have not done a mystery challenge on Web Security Academy before, you have basically two outs. You can click Reveal Objective, which tells you what the objective is. Basically, could be something like login as the admin account, or delete certain user. Generally speaking, if they give you an exploit server, you have to use it. Submit solution is generally always there, I think, so don't quote me on that actually. But we have a short list of stuff it could be. Like if I go back to here, right? It's not going to be anything like DOM-based XSS, it's not going to be request smuggling or SQL injection, it's going to be one of these vulnerabilities. So what we'll do is we'll have a look around. Also, if we have an account, they do give us credentials, Wiener and Peter. So I guess the key thing here is log in. Okay. We have an API key. Let's go into burp. Get account details. A lot of these we have seen before, so I'm not going to pretend that everyone on the stream was here the last two times. This one does seem quite familiar. I suspect we're supposed to get the API key of another user. Let's go back and see. Let's go to the exploit server and see what we can do, because the exploit server does change based on what you have. So we don't, for instance, have a mail client. So it's nothing to do with email. We can store an exploit as a web page, and then we can deliver it to an exploit to a victim. That just means they will visit our web page in a certain browser. So I wonder if it's supposed to be some kind of cross-origin request something. What I'm guessing is we're supposed to get this, right? Which means we need to get them to send a GET request to account details, and then we need to extract the API key. So let's do JavaScript. There we go. JavaScript HTTP request. Hacks guy, subscribing with Prime. Thank you so much. So I think this is what we used last time, to be honest. So we'll copy this and we'll put it back in the exploit server here. It's going to be an HTML page, so we need to at least create that, put a body in there, put a script tag in there, and then obviously seal it all up. So what does this do? This creates a constant called HTTP, which equals a new XML HTTP request object. Remember I was talking about that when I was talking about spars. This has absolutely nothing to do with XML. This is just what it's called, and I don't know. It's called XML because it was originally a feature called AJAX, which is asynchronous JavaScript and XML. Yeah, they really did make the and part of the acronym, which is kind of annoying. But the idea being you would send an XML object behind the scenes and get information back, and there was really no need. You could send anything. So what we need to do is set the URL to this. I think right. So we set the URL for that. We're gonna use the XML HTTP request to open, which basically means create a new request. It's going to be a GET request. It's going to be to this URL. We're then going to send it, and then on ready state change is pretty much when the response comes back. We can get the response text, but we really want to make sure the credentials are set. So there is a way of setting credentials. Actually, can we just use fetch? We could try fetch later. I think there's a way to hang on. XML HTTP request use cookies. See, I'm coming into all my search. There we go. It's the with credentials. So if you don't set this value, and we're gonna set it here, HTTP dot with credentials equals true, it won't attach the cookies, which obviously we want. Okay, so if we have this, I don't know why I deleted that. We want to make another request back to our exploit server with the result, which is going to be this stuff. So the easiest way to do that is to do a new image dot source equals, and then we're going to do this. And we'll do A equals. And then we don't want obviously just to take this text because this has nasty new lines in it. At least it probably does, yeah. So we want to convert it to probably base64, which I believe BTOA is the correct way of doing that. We can just test that out in here. Go to the console, B20A, test, yeah. Alright, so let me just double check over everything. We'll obviously test this out on ourselves. I think this is good though. Let's store it. And then we will view exploit. So we're going to do it ourselves. Did it do anything? Okay, there's a no So it did send it. It did send the request. It just didn't grab them. The constant URL is the burp collaborator link? No. Where are we? It's the URL we want them to browse to. Weird. Log out a minute. Is there anything on here we missed? I don't see anything. This is like a shop where you can't actually buy anything. Like there's not even an add to cart link. So it's definitely gonna be okay, I'm trying to think. If it's not going to work for us, it's probably not going to work. If we go to the access log, for instance. 0x Teddington resubscribed. Tier 1, 7 months in a row. Thank you so much. Yes, we see we have this. So the error is... It's been blocked by policy. No access control allow origin header is present. This is where we can go to the learning path. It's entirely possible this isn't cause, but I'm not entirely sure how else we can do it. Where's cause? Oh, I wonder if we have to do it using this. So if the origin is null, will it work? Let's try that. So the problem we're having, right, is when you do a... Okay, I need to send this one. So this was the request that was sent when we visited that page with the JavaScript. So it did send a get account details using my session cookie, and it sets this origin header because it's a cross origin request. Now, the rule is that you have to have an allow for the origin. If you don't allow the origin in the response headers, then the rule that the browser goes is you can't access any of this. So if we do origin null, yep. Okay. So this is a slightly better than the one we did maybe last week or a few weeks ago. And that you can't just do this JavaScript trick, sorry. But you can do this. We'll copy this payload. This is the great thing about the resources, the actual instruction stuff, is you get this quite a nice number of proof of concepts. So we go back. Oh, which click the wrong button. Exploit server. All right, let's. I'm just going to paste in here. So I think we just have to do the same. Yeah, I think we can just do the same stuff we did before. So I think I can just literally copy and paste this back. Okay, let's store that. I'll explain what this does if it works. We'll view the exploit ourselves. And it's happening in an iframe, so let's go to the access log. Okay, that didn't work. Inspect, maybe. Reload that page. Let's see what's happening. Oh, right. I got quotes where there shouldn't be quotes. So I just need to change these double quotes to single quotes. That should be good. Alright, so now let's reload the page. That looks good to me. Go to the access log. And remember, this is me exploiting it. There we go. So if I double click this and copy it, we go back to burp, go to hackverter, paste it in, decode base64. There are my details. So why does this work? So it's using an iframe. And if you used iframes before, it's a way of loading a page within a page. So if you go to this exploit page here, you see out here is the actual page itself. I'm not sure if you can see very well, but if I zoom in, there's this big box. This is an iframe. So this is a page within a page. Now usually with an iframe, you give it. I don't care about that. Usually with an iframe, you give it a URL, right? That kind of makes sense. In this case, you don't. You give it an HTML document, which is effectively embedded in a data string. This thing here. Data strings are kind of crazy, but the idea of them is that you can put any kind of data into a string format and the browser will interpret it as whatever kind of data you tell it. So it's actually kind of a nice way of embedding images into pages without having another request being sent to get the image. You could base64 encode the image, for instance, and then tell the browser using the data string that it's an image that's base64 encoded. In this case, we're telling it that it's an HTML document, which it is. It's basically just a script. So even though it's JavaScript, it's all using HTML, right? And the key thing is that when you do an XML HTTP request from within an iframe, the origin is set to null, because it's not really coming from anywhere that it's not coming from the site you're on, because it's in an iframe. And at the same time, there's no real origin that makes sense, right? Because it's a data string. So we set the origin to null. Basically, we forcibly set the origin to null, which we saw we were able to bypass. That was the thing here. So when I sent this request without the origin set to null, if it was set to an actual URL, we don't get the this thing, access control allow origin. If we do set to null, we get it. That's a common bypass. I don't know why it's set up like that, but it is. So now if we deliver the exploit to victim, and then we go to the access log, scroll down here, I think this is them. Certainly looks like them. So if we copy this, go back to Hackverter, I'm just gonna paste it in here. Yeah, there we go. Username administrator, API key. Usually what they want is the API key to be submitted. So there we go, solved it. Now, did anyone not follow along? Because I understand. Cause is kind of complicated on its own, but the null bypass is a little more complicated. But actually, hang on a minute. Where is? Because I know. Here we go. You go here. Let me load it in. Rana Khalil has this whole. She's creating this whole Web Security Academy series where she basically does all the labs. She just did cause. I think this is lab number 2. So she has a whole video on it. Definitely go subscribe to her. All right, let's try another one. That was good. We haven't seen that particular one before. By the way, I should have mentioned at the beginning of the stream, if there's any background noise, I do apologize. I have the window open because it's like quite hot here today. Okay, we have a submit solution. We have a blog. We have an avatar upload. Interesting. Let's log in. Okay. Oh, battle's ready. Let's switch over to Stream Raiders. Curse these two. That was supposed to be a hard battle. I think only 2 people actually did anything. Well done, GoPro Slow, yeah. Alright, let's move on to here. I'm going to use a rogue, I think. Alright. So we can upload files, we can change emails. Let's see what we have when we inspect. So I wonder. I think last time I created a little image I could use, and now I can't remember where I put it. Give me a sec. No, there it is. Okay. Let's try uploading an image. Can I just drag and drop that into the... I can. The file has been uploaded. Okay. Can we... Is this just a... this could just be a file upload bypass. Like, can we just upload a PHP file? Yep. Will it execute is the next question. Oh, hang on. I think it's files avatars. Yeah. It does. Okay. So, if memory serves me correctly, if you're doing this exploit, what they want you to get is a file, but you can't do code execution, I don't think. Like if we tried to do something like echo shell exec get cmd or something, and call it shell. And do shell cmd equals id. Right, I'm pretty sure they disabled the ability to execute commands. But we can PHP list files in directory. Scan the okay. Alright, let's try that. So we will do, I guess, files.php, echo scan the, and then get, oh actually no, it won't echo, we'll print R, which prints an array. Send that there. And then I want to view page source, because otherwise the formatting is going to be annoying. Do I call it file or files? Files. Directory equals root. No. Did I get that wrong? Scan directory. I could have just should be right, which means they probably disabled it unless they can do home. Okay. There is another way of doing it, isn't there? Glob, I think. See, the thing is, I feel like I believe what we need to get is a file in Carlos's home directory. But if I can't list all the files, it's going to be really annoying. So I think it just does it on for all path names. Okay. I mean, let's try glob. Files 2. Does it need a print R? Yeah, it does. Okay. And I guess we'll do path. Files 2 path equals home. Okay. That's a little better. At least we're getting an array now. What happens if I just do any? Can I just do an asterisk? No. Alright. So we can try. Actually, was I using files 2? No, it was files. So the next thing we can just try is file get contents and just do a print. Can we do lists? No. Okay. So can we do? Let's see, host name. I'm not entirely sure what the goal is. So one of the difficulties with the mystery challenge is when you get an objective that isn't clear. Like, clearly the point of this was to get command, well, at least PHP file execution, which we've got, right? So I'm just going to click reveal objective. Right. See, here it is. So, like, in order to do this lab, you have to know that there's a file called secret in Carlos's directory, which if you've done the lab before, note that I said I think there was something in Carlos's directory we need to grab, but I forgot that it was called secret. So I think we can just paste that in there. Maybe not. File get contents. Do I have one that? Oh, I think I have two. Yeah, I don't have enough parentheses. 4. Oh, maybe I did have enough parentheses. No, I did. So why is this not working? Does it just not like the print? File get contents really should work. Okay, maybe it just wants it to be raw. Just do file 6. File get contents. Oh, Wait, what? No, I did that wrong. File 6. There we go. I guess it was the I guess it only looks for the you have to do it within here. I guess you can't pass parameters down. That's weird. Okay, let me submit the solution. Furry 98. You probably want that. I don't have a dog. I got 3 cats though. Okay. Another one. So I believe we did that one. I got like maybe 2 weeks ago, maybe more. Again, there are only 50 apprentice level stuff, so we're bound to run into the issue of repetition. All right, this is another just submit solution. We don't have. Okay. So this one, let me look at my notes. This one might be brute forcing the username and password, because that is something you can do, and you can use the following username and password list. So let's try that. So what we'll do is we will copy this. This is actually going to be an interesting one because I don't think we've done this before on stream. So if I type, actually, we don't need to type. Let's go to post login. Right, here it was. Go to intruder. So we want to clear everything out. We're going to try and brute force the username first. What was the message we got? Invalid username or password. Okay. Might not be it then. I don't know. We'll see. What we're going to do is we're going to paste in the list of possible usernames. Go to options, and we're going to extract the error. So I'm just going to highlight it, click OK, and hopefully if we click start attack, it should, where am I? So you see it extracts the warning here, invalid username and password. So if we scroll down, do we find one? We do not. Is there a timing attack? So this is the response times. No. Alright, so it's. What are we doing? Right. So this might not be an authentication lab then, which is odd. What else we got? I guess we can view the source and see if we see anything weird. Check robots. Oh, okay. It's this. Admin interface only available to local users. Okay. I think we have to do a trace. No, can't do a trace. Can we do a trace on this? Oh, hang on. Is it track? No. This message, no, this message means only local users, right? So there was a lab we did, I want to say a week ago, where we had to use trace. I think we can just, if we just do a get, but then do maybe localhost. Yeah, that was it. Alright, so let me show you what's going on. So we try to browse to admin, and it says it's only available to local users. If we then hijack the request, intercept it, and Manaso, thank you for the Prime sub. If I intercept the request, refresh the page, and replace the host header, which is literally the only thing telling the web server which host we're going to, right? If I switch it with localhost and turn intercept off, suddenly we're in the admin panel, right? If I click delete now, this won't work, because if I click delete, it's going to say this again, right? So if I go back, if I intercept again, click delete, go back here, again, replace this with localhost, turn intercept off, solve the lab. So yeah, basically the server, the web server, or the web app really, has code in it that says if you're hitting localhost as the host name, like if you're typing http://localhost/admin into your browser, that means that you're able to access the server locally, right? Because that's the only way you would get to that host locally, because localhost always resolves to 127.0.0.1. So that's obviously a mistake, because just because you can type localhost and get it to resolve in the browser to 127.0.0.1 doesn't mean you can't just switch the host header to localhost. You're still sending the request. You're still sending the request to here. Where was the one I used? If I do edited request, what should I do that for? Okay. The host, this is where the request was sent. So it was sent to this https ac4a blah 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 websecurityacademy.net. Right, that's where the request was sent. It wasn't sent to localhost. We're just pretending it was by placing localhost in the host header. And we're basically tricking the server. It's not classed as a server-side request forgery, no, because the request was done client-side. The server didn't make a request. Anytime server-side request forgery is when the request starts at the server side. This would be probably access control, I want to say. You could put this under a few things, but access control is, it is an access control issue. Effectively, you're bypassing the access control. Right. I'm glad that we're getting a few new labs this week. Another submit solution. No login. Blog post with a search, which means highly likely to be some form of cross-site scripting. It's not there, but is it here? Yes, in some way. There we go. So we're injecting into an input tag. Those of you who are watching the stream, I want to say last time we did this, how can we exploit this using XSS? We can't get out of the input tag. We are stuck in this input tag. We can escape out of the value attribute. Yeah, so we can only use certain characters. We can't use greater than, less than. We can use double quotes. We can use forward slashes. Yeah, let's do it. Let's do all the special characters. So double quote, single quote, less than, greater than, and then I honestly forget what an ampersand encodes to. I should really know this off by heart by now, but I don't. URL encode 26. Alright, let's go down. Alright, so we can do double quotes, single quotes, and ampersands. And we need to, I'm telling you, this is XSS. Anyone who was on the stream when we did this last time should remember, if you learned. How do we get XSS here? Crucially, we're in an input tag that is visible. It's a text tag. Anyone? Have we got 50 complete new people? Or does anyone, people just don't remember from last time? Well, let's go to the Portswigger XSS cheat sheet. So this is the greatest tool ever invented for cross-site scripting. And I don't say that lightly. This is, by regularly updated, they do mean it. Like, it was updated last week. So you can select the tag that you can inject into. So like, we can inject into input tags, right? And the browser we're using is Chrome, so we can select that. All events is fine. And now you can just scroll down and find all these different ways of executing cross-site scripting. This is probably the best one, on focus. So the way these event handlers work, you can set event handlers on HTML elements, and they will execute based on certain actions, or I guess certain events. So if you were to set the on focus attribute on this input field, and then click in it, that gives the field focus, or indeed if you were just to tab to it, that's called focusing. It would execute anything we put in the on focus. Alright, so let's show you how that works. So I'm just gonna focus equals, and we'll just do an alert 1. There. Yeah, you can do mouse over. So you see here? So This quote was original in the HTML. This is mine, and then I did space on focus equals. This is my quote, and then alert 1. This quote isn't mine. This is the original end quote to the value attribute. Now what this means is if we click, we get an alert. In fact, we get too many alerts. Because now we can't get out of this. Oh, we can. Okay, good. You can click anywhere else. You can do on mouse over. There, like that. Solve the lab, good. Does anyone remember, maybe this is a bad question to ask, how we automate it, how we get this to execute without us having to mouse over or click? We did this last time on error. The only time you can do on error, if we go back to this cheat sheet, is if we could change the type to image, which we can't, unfortunately. On page load, unfortunately, no. I don't believe you can do on page load. On page load is, or it's on load really, is only for, I think, the body element and iframes. Right, I'll put you out of your misery. There is a fun attribute. It's not really an attribute. It's an attribute with no value called autofocus. But we're going to give it a value of just empty string. This is a special attribute. You can only set one element on the page with an autofocus attribute. Okay. So if there's an element that already has one before this element gets loaded, you can't use this trick. But since there isn't, you can. What autofocus does is it tells the browser once the page is done loading, just like automatically focus on this. Put the cursor in this text box, which can be useful for usability reasons if you want someone to fill out a form and you want their cursor to immediately go into the first box rather than having to click or tab into it. So if we now take this view source out and press enter, we immediately get an alert box, right? Before the page even actually showed us anything. It's loaded, it's just the alert box takes precedent. If we press escape, we get there. And actually, this is in the cheat sheet as well. If I go up to on focus, there it is. It has an autofocus. So you see, it doesn't actually need. It doesn't need any value. So I could have done this another way. I could have put it here. Autofocus, and then taken out all of this, and then it still works. And in the source code, there we go. I just switched it around. I just put an autofocus there. Non-focus equals alert. Generally, this is bad practice for HTML. If you're doing anything according to the HTML specs, every attribute is supposed to have a value, even if it's nothing. But nobody cares about the HTML specs. So, all right, let's do stream readers. I'm gonna curse these guys. Let's curse the first lot. There we go. Little Dee all alone over there. I believe in you. Come on. Is she gonna make it in time? Oh, she got shot off. Nice. Nice victory, guys. Alright. Well done, Just a Guy and Teddington. Alright, very hard. Alright. Everyone really needs to get involved this time. Where should we go? Where should we start off? Let's start off up here. Let's go down this way. Yeah, exactly. This we want. Alright. Let's do another. I missed Big Nicky's. You tier this off topic on current challenge. Would you be able to explain identifying authorization bypassing GraphQL source? Jeez. GraphQL is the only time actually I tell a lie. I've done a test with GraphQL once. I don't tend to see it that often. I mean, I've seen it once, so yeah. And I do maybe between 40 and 50 tests a year. I mostly see it in CTFs. But I mean, GraphQL bypasses are generally done at the like the cookie or auth header level, rather than anything to do with the actual GraphQL thing. The biggest vulnerability in GraphQL is introspection, which if you go to Actrix, GraphQL, like this. Yeah, by default, GraphQL does not implement authentication. So yeah, a lot of the time, there's not even a way to authenticate. You just authenticate prior to it, and it's not necessarily a vulnerability if you're able to query GraphQL without authentication. It really depends. I mean, it depends on the type of data that you're dealing with. If it's supposed to be a publicly facing data set, then there's no reason why you would need authentication. Yeah, Insider PhD did do a video on it. Did we? Yeah, this is a new challenge. Okay. Alright, let's have a look. We have... Oh, we have a check stock, which means it's XXE. I know this one by heart. Oh no, it's not XXE. It's, there we go, here's a server-side request forgery. I forgot they use the check API for this. Stock API, sorry. So, as you can see, when we issue a stock check request for this hydrated cracker in London, we get 712 units. But the way it does this is it sends, if you can see this, stock API equals this decoded value, stock.weliketoshop.net, port 8080, product stock check, product ID equals 1, and store ID equals 1. So this is a server-side request, right? We're telling the server to go to this URL. So obviously one thing we can try is just going, again, internal server, if we just go there. What happens if we just do 8080? Missing parameter. Could not connect to external stock service. Is it HTTPS? No. Can we connect back to this? Basically, I'm just trying to see what we can reach. We can reach this. What happens if we just do HTTP? We get a redirect. Okay, what happens if we do localhost? Internal server error. If we change it to HTTP, there we go. So again, this was kind of very similar to the last one, where by putting localhost as the host name, we could get to the admin page. The difference here, somebody asked if that was a server-side request forgery, so they were kind of it was like a premonition for this one, because this is pretty much identical with a server-side request forgery. So if we view localhost/admin and scroll down, you can see this. I mean, let me just render the page actually. There you go. So we're now in the admin panel, despite not being anywhere near the admin panel. Anyone not understand what we did there? To be honest, we can even take out this nonsense. We can do that. This was a more obvious one. Yeah, well, we're at admin rights because the authentication or authorization assumption of this admin panel is that if you can reach it via localhost, you must be on the server. And if you're on the server, you must be an admin. Right? Which, to be fair, is not too bad of an assumption. But you should never trust the host header, firstly. You should basically every web server knows which IP address connected to it, right? That's part of what you can query if you're a web developer. So you could do a check to see whether the actual IP address is localhost. If you do that, you get into some problems if you use x forwarded for. Forwarded for. Because if we do this, some web servers will basically interpret this as the IP address that you're coming from. If they do, there's always a kind of like a real IP. So actually, if we look up the PHP $_server, I only use PHP because it's what I, to be honest, know. It's the easiest one to get to. So they have server address, isn't it? Right, so we got remote address, remote host. There is one, I believe. Actually, so I think remote address is correct. I think that does use the actual address. It can depend on the actual web server itself. But yeah, you don't want to use remote host. Okay. Anyway, if we go back here and we just copy this, we can delete Carlos, which is the point of this lab. I think we did it. Yeah. Yeah, it's not bad logic. It definitely is flawed. Alright, so mean, is this just going to be... This is just going to be XSS again. Depending on... Alright. So, it's kind of... DOM XSS, to be quite honest with you. They don't class this as DOM XSS, but it kind of is. And the reason I class this as DOM XSS is if you search for, like I just did ASDF, right? If you search for ASDF in the source code, you get nothing, right? Which means it's not reflected XSS, and it's certainly not stored XSS. Which means, it pretty much has to be DOM XSS, or potentially client-side template injection, but it's not that. So I don't understand why this isn't in the DOM XSS section. Either way, we can still inject. All this is doing, we saw this last time, we have a JavaScript function doSearchQuery, which takes a query parameter. It then queries the DOM. This is what makes it DOM XSS. It gets all elements where the ID is search message, which is just this one here. And then it sets the inner HTML, i.e. all the stuff in between those two things, equal to whatever was passed to it via the query parameter. That's just defining a function. It does nothing right now. It then creates a variable called query, which via a long-winded process just grabs whatever value search is set to in the URL. So in this case, it's set to this. And then if there is a query variable, basically if I did pass it something, it just runs the function. So all this is effectively doing is copying whatever's here and putting it between these two tags. Now it doesn't do this in the source code, it does this in the DOM, which is why in the source code nothing's changed. But if we look at the DOM, if we right click, inspect, if you've ever done this, this is the DOM. This is what you're looking at. Alright. So if we hover over this, we go span, 0 search results 4, there's the search message, there it is. Alright, it's been inserted into the DOM, but the DOM does not update the source code. The source code always remains static. So how do we exploit this? You might be thinking we can do script alert 1, which we can't do, even though it's there. I'm not entirely sure the reason why, but all I know is that if you inject script tags into the DOM, they just don't execute. It probably has something to do with how JavaScript is rendered. For whatever reason, though, they just don't execute. So, again, people who watched the previous stream, do you know how to exploit this? Any ideas? I'm going to take that as a no. We use events again. So JavaScript will still execute in event handlers. The easiest way to do this is with an image object. If we were to do an image and give it a source, usually when you do an image source, you would right click this image, get the source, paste it in there. But we don't want to do that. We just want to put an A there. What does this do? This forces the image tag to load effectively this page, right? This URL /A, which is a 404. At least it should be in here. Yeah, right? It's a 404. A doesn't exist. So this causes the image tag to throw an error because it can't load the image. And so you can just use onError. Alright? onError will run whatever we tell it to whenever there's an error in this tag. And when the tag attempts to load this, it'll get a 404, so obviously the image doesn't exist, which means it throws an error, which means it alerts. Boom. And you get this cool graphic of a broken image. There are other ones. There's a really cool one. SVG onload. So SVG onload works, I believe. Yeah. SVGs are weird though, so there was a time, it's probably less relevant now, when WAFs would just block image onError, and you could get around it by doing SVG and then no space and then onload equals, and they would sometimes block error as well, so you just do prompt or confirm is a better one actually, right? And then you get pretty much the identical thing. And the reason you can use where is it? The reason you can use /s to separate them, I have no idea. I just know you can. It doesn't work with everything, but for some reason you can do that. You know what? Let's do a practitioner, but let's choose something. Because I don't think choosing any is going to be very good. Nobody really wants to see directory traversal because that's pretty easy. We could try server-side template injection. I have no promises it's going to work. Again, I've only done 96 out of these 130. I can't remember which ones I've done. Server-side template injection, though, I believe we should be okay. The real thing is going to be whatever the objective is. Now I have a I have my own list of fuzzing payloads I use for these. So first, let's see if we can find any nice instance. Oh, we have a message. All right. So there's a message attribute which, like if I just put test in there, it gets reflected back to test. Brown Disappointment, thank you for the follow. Funny username. So we go to this get test thing, go to intruder, I can take out this session cookie. We don't need to fuzz that. I'm just going to paste in my list. This is quite a nice list of payloads. And then we are going to go to options, extract, find where it reflected back test. And that's all we want to do. And then we'll start the attack. Cool. So these payloads, this one just fuzzes for general server-side template injection stuff. These are all specific attacks, and effectively all they're trying to do is execute 7x7 and return it. So you see here, this was $ curly brace 7x7 close curly brace close curly brace, and it all got reflected back the same. Same with this one, this one, this one, this one, this one. This one though, this open triangle bracket percentage equals 7x7 percentage close triangle bracket became a 49. Interesting. We can confirm that even more so if we just copy this, put it in here, right? We don't have to do 7x7. We could do 7x8. All right. But the point is, now we know at least one format. So now we can go to Portswigger SSTI, and they have a great resource in the form of flowchart. Here it is. So we know that this one didn't work, and we know that this one didn't work. So it says it's not vulnerable, but it is vulnerable. There's a specific version. It's actually in the blog post. I'm in the wrong section. I think it's here. If I do... Is it Mako? So I think it's Mako. Mako template injection. Yeah, so we could have just really just gone to this page. That's good as well, I guess. If we search for what we had, which was open triangular bracket percentage. I guess there's a Ruby one. This could be Ruby. Also could be Mako. Let's try Mako. That looks fun. Bear in mind, it might not be Mako. But what we'll do is we'll just URL encode all that. So what this is doing is executing ID on the server, reading it, setting it to the variable X, and then we're using the variable. So if this doesn't work, we know it's probably not Mako. It's probably that Ruby one. Well, that gives it that's a good clue. We get Ruby errors, so we're definitely in Ruby. Alright, so if we go back up, let's try this one. I notice chat's gone very quiet. Is this too advanced for everyone, or are we doing alright? So this should just list all the files. There we go. List everything in the if it's all right. So we just literally ran dir.entries on the root directory. So again, we don't know what we need to retrieve, right? Because it's a mystery challenge. Let's assume it's the host name. So if we do file open etc host name and copy this, all I'm doing here is URL encoding it, by the way. All right, that probably is the answer. No, okay. So maybe there's something in Carlos's home directory. What am I looking at? Let's do another dir.entries, but we'll do it on /home. See if there's anything in there. Okay. Elma or Carlos, I guess. Don't know why I even did that. I can just put it in here. Morale.txt. So now we can read the file. Okay, just gonna put it down here. Home Carlos morale.txt and URL encode it. Okay. That's clearly not what we wanted. What? Can we get just code execution? Let's try it. Ruby SSTI code execution. I imagine it's pretty simple. Let's go to Hacktricks. That's a good site. Ruby. There we go. Oh, you just use system. Much easier. Or even just backticks, I guess. Let's try that. So if I get rid of all this, can I just do backticks ID? I don't need that last one. Alright. So sometimes, again, we could hit real objective. I'm pretty sure what we need to do is remove the morale.txt file. Let's copy it first, just to make sure. Carlos morale.txt to home Carlos morale2.txt. Okay. Let's do an ls -l on actually just on this home directory. Okay, we have a backup, so let's just remove it and see if that's what we were supposed to do. It was. Nice. Battle. Okay, yes. Just in time. Look at that. Alright, I'm gonna curse these guys. Why did you all cluster down here? Well, this is gonna be interesting. I think we're doing pretty good. Some of these people are very sprightly. Oh, that's because he's a level 30. Okay. Very good. Well done, everybody. B Shorty. I don't believe I've seen you on the stream before. Welcome. Well done. Okay, we'll do this one. This is hard. I'm gonna use my rogue again, I guess. There we go. Alright, that was slightly easier than I was anticipating. I guess we could try a practitioner level XXE, which might hopefully be something a bit more complicated. So I've done several videos on XXE. If you go to my YouTube, I'm pretty sure one of my first streams was about XXE. This is an interesting one. If I remember with this one, you were supposed to convert it. I don't know why they even did this. Like if you can take this to text/XML, and then you do like stock product ID. And then store ID. Maybe not. Can we do... Did I actually... Yeah. That's a very strange one. I wonder if it's if this is XXE, this might be X include instead. Let me just try something. Let me try just doing a. Alright, yeah, so we're injecting, instead of this being traditional XXE, we're injecting into an XML document. Right? Which means we can do X include. So XXE X include. Where's the X include? Come on. X include. Here we go. X include is even easier. You just literally like do this.
The year is
Also, it helps at the fact that if you like type test there, it gets reflected back. I need to URL encode all this. There you go. Was that the yeah. So yeah, in that case, that wasn't really XXE. It was mostly just injecting into XML and knowing about X-include. But again, this isn't a very common thing, to be honest with you. The clue is when you do something like product ID 1. And if you do something like 1A, it says invalid product ID, but then you surround it by whatever, right? So some random tag, make sure it's the same closing tag, and you still get the same answer. And that's because the code that extracts the product ID is effectively just going to recur. If you ask it to get the text value of the product ID, let's do an example. So let's say you had something like this product, and that was the 1, right? If you ask for the text value of the product, right, it's clearly 1. If you put that in there, the text value of product is still 1, because this isn't text, this is a tag. Right? That's why that still works. Like, it's weird, but it kind of makes sense. Yeah. Since it says Windows, where does it say Windows? Did I miss something? Yeah, the tag can be anything. That's the beauty of XML. There's literally, you can do any kind of tag you want. All right. I don't know where you saw Windows then. Oh, in the headers? Oh. Yeah, that's just because I'm on Windows. That's just added by the browser. I'm on my Windows machine right now, so. Okay. Let's do... that wasn't really XXE, so let's do another one. I don't really count it as XXE anymore. It's more like XML injection. Okay. So if we check stock this time, we actually get XML being submitted. This is cool. Okay. So let me get my my XXE code stuff up. So if we do sorry, I'm gonna split it like this so we get to see the whole thing. So we do a stock check. We get 376. So we can test to see if XML entities are even enabled by doing this. Entities are not allowed. Oh no. Don't use Portswigger XSC materials and payload. Yeah, kind of. I mean, I have a bunch of other ones. I guess the question then is, can we? If we don't reference it, what happens? Do we still get the error? No. So this one is probably going to be using parameter entities, which are even weirder. You can't just encode everything, no. So where's a good? Just trying to think of a payload. Let's go back to the exploit server here. Grab our exploit server URL. So we can test to see if parameter entities are supported by creating a parameter entity, external entity, setting it to this, and so this is our exploit server URL. Just put /xxe, and then crucially, we're still in the doc type here. Then we call xxe using percentages. XML parsing error. That's nice. Did we get a hit? We did. So we can use an external DTD, I believe. Let me copy one. All right. Let's call this exploit.dtd. You don't actually need to, but I like doing it. So we'll change this. We're not going to use the burp collaborator. We're going to use the exploit server because why not? Okay. Store this. And then if we change this to this is the freakiest thing about XXE if it works. Refresh. Yeah. Okay, so we just extracted the host name of the box using this completely crazy thing, which I will now attempt to explain. So this is a doc type definition file, a DTD, right? The first thing it does is it defines an external parameter entity. It's a parameter because of the percentage, called file, which is going to, well, it's set to a string, file, colon, and then 3 // etc /hostname. So effectively this is just a file path, right? But it's currently just a string. We then define another entity, parameter entity called eval. This is not an external entity, it has no system, right? So it's just a string, it's just an internal entity. However, the string is a string defining another entity. So this is just a string, remember? So it's the string version of pretty much this, right? So it's defining an entity, This is just a percentage encoded. So it's it's a parameter entity called exfiltrate. It's external, and it goes to exploit blah 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 web security academy.net $x equals and then percentage file semicolon. Right? So this is still a string, but it's a string that represents an external parameter entity, which then in the entity itself references another external parameter entity, i.e. this one. Right. This is the and this bit is the freakiest thing. You then you will then reference eval, the eval entity. It's just referencing it, right? Referencing it for some reason. And I don't know who invented this or thought it was a good idea, but if you reference an internal entity that itself defines a string which is an entity, it will then define that entity. So, so at this point here, right, if we're going line by line, at this point, the entity file is created, except that this doesn't do anything. This is just a string, still, but this is an entity. At this point, the entity eval is created. At this point, the entity eval is referenced, which then creates this entity, right? Exfiltrate. But at this point, even still, exfiltrate hasn't done anything. It doesn't make a call out to this or anything, right? But at this point, by the end of line 3, we now have a new entity called exfiltrate, which we then reference. And by referencing this, the XML parser is going to look at the string and it's going to go, oh, I need to go to HTTPS, blah, 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 blah. And I need to set x equal to percentage file semicolon. Oh, that's another external entity. I better go see what that wants. And so it goes back to file and it says, oh, what does file want? It wants the host name, right? It wants to read /, it's just basically this, /etc hostname. So at this point, it reads /etc hostname. And then it sticks it on the end of here, and then it sends a request. Right? And then we get requests. So you see here, we get 2 requests. It loaded the external DTD, which is what we did here. All we did was reference it, by the way. We just created a new parameter entity, and we pointed it to the external DTD, and then we immediately referenced it. And again, for some reason, just referencing an external DTD as an entity loads the doc type definition. Why? Who knows? This is why XXC is just completely broken. It's insanely stupid. And then we get this. So this is the host name of the box. Now we could try a few things. Depending on how lenient it is, you might be able to get the first line of the password file. This doesn't always work, but we can certainly try. Yeah, we didn't. But so this is Java, so I think Java it'll only read the first line. So I'm trying to think of other files in Linux which only have 1 line in them. That's why hostname's so good. I'm trying to think. Yeah, I can't think of one. Hostname is pretty much, it's like the go-to. I don't really understand what the HTTPS exploit Web Security Academy link does or where it is from. You mean this bit? This or this one? The one in Burp or the one in the browser? Yes, okay, so both. It's the issue. Oh yeah, maybe. Let's try it. And then we'll get back to just a go. It's the issue. No, didn't work. Alright, the one in the browser. Okay. So this one is literally just to deliver us the value of the file, right? I guess it might be easier to show it if I change this from just file, right? So I remove the external part and I just set this to a string. Hello, just a guy. Store that. See if that works. Should do. Yeah, there you go. Yeah, so the first request obviously is to actually fetch this exploit.dtd file. And then this is just to deliver us because nothing's being returned in here. We're just getting XML parsing errors, right? So we're not going to be able to retrieve any data in the response here. So we have to do it via an out of bounds request. Yeah. Sometimes you can get responses back, but in this case, no. All right. Oh, I should probably, actually complete the lab. That would be good. Oh, there we go. Submit solution. You're welcome. XXE is just, I don't know. It still even confuses me sometimes. I'm mostly confused by why anyone thought it was a good idea. Okay. Maybe we'll try one more. It's kind of like JavaScript, right? Yeah, true. I'm trying to think of something we can do quickly before I call it a night. I guess we could try an authentication. Web cache poisoning. The labs last time I tried were kind of. I guess we could do one. You know what? Let's try it. No, no promises. The labs sometimes are a bit weird. But look, web cache poisoning is extremely funny when done properly. I can close down this attack. We don't need it anymore. All right. So. trying to find where it's loaded. Is there a login at all? No. Okay, good. So I'm imagining if we what if we just do test stop? Not found. Okay, so we need to presumably T equals. So the way web cache poisoning works, you first have to find some kind of parameter in the request, which gets reflected back in the response, and then it doesn't affect the cache key. So actually this cookie might, because I just noticed fe host equals test. Yeah. Can you add an extra? Yeah, you can sometimes do that. Yeah, look, Barry Duino found new emojis. Let me do this. Trying to see where it's actually used. Maybe it's used on one of these pages. So we're probably going to have to break out of this. Can we do a URL encoded one? Come on. Yes. Okay. So we can break out. So you see the cookie fe host is getting reflected in here. And actually I should be setting that every time. So this parameter here, make sure I'm not caching anything. So if I do plus alert 1 plus %22, I probably need to URL encode that. Okay, so we have a cross-site scripting thing that only affects me, right? So if I copy this cookie value and I put it into my cookies, I don't know why these are all. Oops, well, that screwed me, didn't it? There we go. Okay, so if I put this in here, no, I just need a new. I need to create a new cookie, fe host, and then kill this one. What is going on? I guess I need to put the domain info in it. Session, sure, secure. that work? It's a bit weird with the the cookie setting of this. So if I intercept the response, then at least I can do it. So I'm going to refresh this page. We're going to send that in, and then we're going to intercept the response and set the cookie. This is... Oh. There we go. Oh my god. Why didn't it copy? Come on. There we go. Forward, intercept off. Okay. View page source. That's not actually working. If we delete this one. And this one, and then refresh. There we go. Right, so I've set a cookie which has a value, right, this thing, that reflects back in some JavaScript and effectively just creates an alert box, right? So when I refresh, I get an alert, but this only affects me, of course, right? Only if I can trick the this thing into thinking that I lost it. If I can trick the web cache into caching it, right, caching my response, then it will get reflected back in everybody's responses. Okay, let's do the battle quickly and then we'll do that. Web cache poisoning is another one that's kind of difficult to wrap your head around. Nicely done. Well done, little DD and Teddington. Alright, that'll be enough for tonight because we'll try and get this one done. So, if you see this age equals 0 x cache miss, this pretty much just means that the response wasn't cached, right? This response isn't cached. But if you keep sending it, there we go, you get an X cache hit. Okay, which means if we remove this cookie, we still get the value reflected back, right? Because it's been cached. You see, there's nothing being reflected here. Okay, until eventually we get a miss and it goes back to normal. Does that make sense for everyone? And this is why this was important, right? This is an anti-caching parameter, which basically means I'm only saving the I'm only overwriting or poisoning the cache for this URL, right? Where I have a parameter a equals ASDF. Okay, so if I keep doing this until I get a hit again, right? There's oh no, hang on. There's the hit. Okay, so I remove the cookie. Still get it, but then if I take out this, it goes back to normal, right? Because only this page is cached. Still cached there, though. Okay. This is burp. This is burp suite. So now we've poisoned this, we actually just want to poison the root, right? We want to poison the actual page, which is when we take out this cache busting header. So if we keep sending it, eventually, there we go, cache hit, and if I keep doing this, we should eventually get a solved. assuming that actually causing an alert was, yep, it was. We solved. So the objective there was causing an alert in somebody else's browser. Effectively, they had another robot loading the page constantly, and if the alert box ever popped, it would solve all that. So they will not understand that. I understand that's pretty tricky to understand. We're not inserting a parameter in the header, we're inserting it in here. But yeah. So the way caches work is they operate on a cache key. Now, the cache key generally means... so it's generally a combination of the host and the parameters. And then I want to say HTTP or HTTPS. Let's actually view the topics because they do talk about cache keys nicely in here. Web cache poisoning. Right, cache key, request line and host header. Okay, so that's what they go off. They go off this bit and this bit. Okay? The idea being, if you've got a page that's static, or at least doesn't change that often, you don't want to have to load it from the web server every single time. So you can cache it. And how do you generate the cache? Well, you effectively grab the response from someone else's request, right? And you store that for X amount of minutes or seconds. In this case, I basically said, okay, only cache this page, right? While we were doing testing, and that was just to stop it from caching what we were doing normally. And once I had this working, so once we got this cache hit, I can check that it actually works by removing the cookie, and we still get this, right? So they stored this page, right? When we get X cache hit, they stored all of this. So even when I remove the cookie, I'm still going to this page, still includes our poisoned stuff. And then, yeah, once you've got that confirmed, you could just repeat the attack on the actual index page. Hopefully that makes sense. Any questions about any of that or anything we covered earlier in the stream before I go? I'm gonna see who is streaming. Security Weekly and Security FWD I've never seen before. What are they doing? They're doing a live hacking Q&A. Okay, what's Security Weekly doing? Just their podcast. Let's do the Q&A. That sounds good. Alright, we'll raid Security FWD. Before we do, let me flash up the stream ending. Please follow me on Twitter, join the Discord server, subscribe to my YouTube channel, and please give me a follow on Twitch if you have not already. Hope everybody has a nice rest of the week. I will likely see you on Friday for Frustration Friday, which we haven't done in a while, so that should be extra frustrating. But yeah, thank you for staying with me for the stream. Thank you for all the follows and subs, very much appreciated, and I will see you next time.